In this pencast, we're going to be talking about plotting the sum or the difference of the complex numbers. So first, let's go over how we add or subtract complex numbers. If we have two different complex numbers, let's say a plus bi and c plus di, and we add them together, so we're summing them. We add the real parts together, and we add that to our adding the imaginary part, so b plus di. So again, let's taking real plus imaginary. Similarly, if we're taking the difference, let's say we have the same two complex numbers, so a plus bi and c plus di. We subtract them, so we're taking the difference. We take the difference of the real numbers and the difference of the imaginary numbers, and we subtract them. We add them. So we take the difference of each part, the difference of the real and imaginary, and we add those two together. Okay, so if we have, for example, letter A, we're asked to simplify 4 minus I plus the quantity 3 plus 2i. So first, let's see. I'm going to rewrite it quick. Okay, so first let's find our real parts. So the 4 is real, and the 3 is real. And the negative I is imaginary, and the positive 2i is imaginary. And if we put these into our variables, a equals 4, b equals negative 1, c equals 3, and d equals 2, which means if we put these into our formula, it's 4 plus 3 plus, and then b negative 1 plus d, which is 2, times I, which if we simplify gives us 7 plus 1i, which is the same thing as 7 plus I. And you can see that makes sense because it's taking the real parts and adding them together, so 4 plus 3, which is 7, and we're taking the imaginary parts and adding them together, which is negative 1 plus 2i, so it's positive 1i, and then we're adding those two solutions together, giving us 7 plus I. Okay, B asks us 7 minus 5i minus 1 minus 5i, the quantity. So since we have a subtraction sign here, it's going to be a difference. So we take our real numbers and subtract them, so 7 minus 1. And we take our imaginary numbers and subtract them, so minus 5 minus minus 5, quantity times I, and we add those two terms together. And when we do that, we see that we get 6 plus minus 5 plus 5 times I, which is 6 plus 0i, which is 6. And when you're doing difference of complex numbers, just be sure to be careful about your negative signs because they can pile up and then get kind of confusing. And also note that we get a 6, which is just a real number, but you can always rewrite a real number as the sum of its real part plus 0 times its imaginary. So that's something that you're going to want to remember, especially when we come to part C, which asks us to simplify 6 minus minus 2 plus 9i plus the quantity negative 8 plus 4i. Now, you could think to yourself, oh, I see a real number and two complex numbers, so I'm going to add the complex and then add that to the real. But you ought to remember that the standard for doing this type of problem is to always work from the left to the right as much as possible. So we're in fact going to rewrite this as this real number here as its real and complex part. So it's actually 6 plus 0i minus the quantity minus 2 plus 9i plus the quantity negative 8 plus 4i. So that's kind of taking the concept we learned in part B and applying it here. Because if you did it the other way, you will get a different answer. So always remember left to right as much as possible. And now we can just take the first two terms and do them together using a difference because of this minus sign. And then take that result and add it to the last term here using a sum because of the plus there, and then plot our results. So step one is a difference. And if we follow our pattern, we take the subtraction, or the difference of the reals. So we have 6 minus negative 2, and we add that to the difference of the reals, of the imaginaries, which is 0 minus 9 quantity times I, and then we just write the remaining stuff after it. And always remember to write every part of your equation every time. So you might think, oh, I don't care about the plus and minus 8 plus 4i right now, so why should I write it? But a big mistake is not writing it and then forgetting about it. So always write all your information. It takes a little bit more time, but you definitely will get the answer correct most of the time, at least more than if you don't write it down. So if we do some simplification, we see that 6 minus a negative 2 is 6 plus 2, plus a negative 9i, plus a negative 8 plus 4i, and that equals 8 minus 9i plus negative 8 plus 4i. And now we can do part 2, which was a sum. And so we do the exact same way we did part A. So we say that we are summing the real parts. So 8 plus a negative 8. And then we add that to the summation of the imaginary. So negative 9 plus 4i. And this equals 0 plus negative 5 times I, which is the same thing as negative 5i. So kind of like part B, we can also rewrite an imaginary number, a purely imaginary number, so negative 5i, as the addition of its real part and itself, so 0 plus negative 5i, or 0 minus 5i. So both purely imaginary and purely real numbers can be written in terms of either their complex or real parts. Okay, so I've gone ahead and drawn an axis here on the bottom right-hand corner. That corresponds to our real imaginary axis, which is our complex plane. And we're going to go ahead and plot these just like we normally do, remembering that the x-axis is now the real axis and the y-axis is now the imaginary axis. So for letter A, we're to plot 7 plus I, which means 7 units on the real plane or real axis and positive 1 units on the imaginary axis. So we're going to go over here to 7 and up 1 to right here. This is point A, and it is 7 plus I. For point B, we're plotting 6 plus 0i, or just 6. So we're going to be 6 units on the real and 0 units on the I. So this is B, and this is 6 plus 0i. And lastly, point C, which is negative 5i, which is the same thing as 0 minus 5i, so 0 on the real and negative 5 on the imaginary, which is going to be right here. This is point C at 0 minus 5i. And that is how you plot the sum or the difference of complex numbers.